Switch. Whatever. Maybe I just don't. Maybe we just stay here because I'm sort of rushing. All right. We're live. We're in screen. You're in screen. Not much more I can do. Could go a little wider here. Let me double check our mic. Far mute 345. Okay, that looks pretty good. We got a couple more minutes. We'll wait for some people to come in. We got a couple more. Nice.
Mic is good.
All righty there, man. It's another week. Another week. We're gonna give everybody a few more minutes to get in. I didn't look at the we were so busy today. I didn't sort of Twitter. Let's see, did the team countdown. I'll just repost that. Nobody can see what I'm doing. I don't want anybody seeing this right now. Repost that one. And these are mostly for me. What do we get? Like 5 people watching.
Last one was pretty good.
Well, that I don't know, but I had Thorsten on.
Yeah.
Oh, what the heck? That guy's gonna bring some people around. I don't see the Ardan thing on LinkedIn though. That's fine. All right. Oh, all right. A couple more minutes there. So, you didn't even get your coffee this morning.
I did.
I did. You coffee?
Oh yeah.
Oh, all right.
You didn't get the coffee?
I made it. She had to go to the dog needed the shot, so I had to make it myself. Remember? Well, not that you remember that, but I didn't make it myself. I have to say, I did the sugar perfectly today. I was really impressed with myself. Allie just walked by. I should have taken a picture. It was the best sugar I've done.
The gringo coffee was good today.
I don't know.
It was good.
My brain has to operate at these like measurements. So like I poured just the right amount of coffee in it, but I almost want to get a little cup that I can measure it. And then I know I'm putting the right, you know what I'm saying?
Yeah.
What should I do to connect to Tailscale? We have to do that offline, dude, because I got to add you to a group that I have. So, just send me an email, Mohammed, and we'll get that set up because it's not enough to just install it. You have to get connected to a team group, which I know there's security there. So
yeah, you have to send them an invite and then
there's a bunch of stuff. So
thing.
I think that would be we have today and tomorrow for you to do that. So just send that email, man. That's what we're gonna have to do. Okay. It's 11 o'clock now, so we're right there on time. What do we got? We have 5 people. All right, cool. So, Kevin, what I thought we do this morning. Oh, I didn't even bring the project up. Hold on. Actually, do I have us on this next screen? Yeah.
Yep, we're there.
Okay. Don't you think I shouldn't be using a circle now that we're
together? Yeah.
I should use like a
square. I think square would work.
You think square would work?
We just have to move it. Yeah. There we go. I think that works.
Dude, why is that camera so far? That's the same camera as this one?
Yeah.
I know, but you can see how fat I'm getting on that screen. That's not good, man. That's not good. It's always my head, dude. How's that possible? I guess I can't fix that. Everybody say, "Oh, getting fat, dude." I'm trying to play pickleball. Is the problem?
No,
Are you sure it's the same camera as this, or is it a different camera?
It might be.
That's got to be a different camera.
Unless it's just not using the cropping that we're using on the. Yeah, it's using it. It's using the right one.
Yeah.
It just might not be using the cropping we do on this one.
Yeah, I know. Why is that? All right, whatever. I'm not going to look at that. Okay, so my daughter's pregnant, so this is like I'm gonna be a grandfather, man.
Ah,
yeah, I know.
congrats.
Well, I was right. Well, we still got some time to go. Okay, what I thought we'd do for this maybe first hour, because I didn't even bring this up here. I got our project here, but I've been playing with an AI agent because I wanted to learn how all the AI agent stuff works. And I'm also trying to think how we can incorporate maybe the agent into the chat system. Like there's some ideas there. Actually, I have 0 ideas, but I thought what might be fun for the first hour is to sort of maybe create a hack folder here and sort of walk everybody through the idea of what an agent is, like a coding, in our case, maybe a coding aid, but an agent is. So when you're using AMP, like we're using here, or cursor, or whatever that is, how come I can't get out of this settings?
I think you just clicked the thread again.
Where?
Yeah, okay, there we go.
Oh,
I
I'm
got
there.
it.
Yeah, that was confusing. Anyway, right, there's a piece of software running here, which we call an agent, and agents could have sub-agents that do very specific things. And what was nice was we had Thorsten Ball on last week, right? And he wrote this, Thorsten Ball wrote this blog post, how to build an agent. And it was essentially using Anthropic's APIs to do it all. And I wanted to sort of go through this, but I don't have an Anthropic API key, and I don't want to pay Anthropic directly. I'm already paid Cursor.
Yep.
I'm paying SourceGraph for their time.
Mm-hmm.
And I really like being able to run locally when I can. These agents need the models that are out there. Thorsten's right there. But basically, I wanted to take this but not use Anthropic. And so
Yeah.
I had to figure out how we could leverage essentially Ollama. And one of the models that exists that do support tool calling. Now, Ollama does say online that the llama models do work, but no, that wasn't it. Oh, yeah. They did say that the tooling, that the Llama 3.1 and 3.2 models work with tool calling under Ollama. They don't work, dude. I
No.
lost a day thinking that my code was broken.
Mm-hmm.
These models, if I switch from Quen to this, you will not see the same behavior. Luckily, Quen does work really well, and Quen 3 is their latest. And Quen 3 also has good support for coding.
Okay.
We'll be using their smallest model, which is the 8B, which is great if you're watching because to download this is like super fast.
Yeah.
Wow,
142 gigabytes.
Yeah, no, you wouldn't be able to run this locally.
No.
The 30B I could run on this Mac for sure. But for what I'm doing, I don't really need it, right?
Yeah.
But if I was going to use this as a way to say on the plane when I'm not connected, though it's so easy to get connected today. But anyway, that will never run on my machine. I think these could, but I'm using the 8B and it's fine. But I'm using Quen 3. It did work. It does support the tool calling really well. Everything's a little, everything's got bugs and whatever, but we worked through them. So I went through this blog post, kept the code I could, and I had to replace the code that I needed to talk to Ollama.
Mm-hmm.
So if you're going to follow along in the next hour, the best thing to do is, let me go back to install. Where's the install? I got my, here it is.
There.
Okay.
Yep.
You're going to need to install Ollama if you haven't already. And you're going to want to pull the Quen 3 8B model from there. And you're going to want to have these models loaded on your machine there. So with Ollama running and Quen 3 running, we can actually start. Well, you can't do the pull until Ollama started. So essentially the order is going to be install Ollama. Then you can run this Ollama up, which I'm going to do here, which I did here. Now, when I run these things, I like to keep everything together. So I tell Ollama where to put these models.
Okay.
Now, what sucks is if I go into another project, I have to do that again. So you may or may not want to set the Ollama models folder and just do an Ollama serve. And then from your user root, it will create I think a .ollama folder.
Yeah.
And everything will be global.
Exactly.
But whatever, this is what I'm doing. And everything will sit under, and I did it under Docker. I wanted to run Ollama under Docker, but there is no support for accessing your GPU. It's a bummer. So that's why you'll see in this project a compose up and an Ollama up, because if I run Ollama in compose, it will be CPU, not GPU, and it will be way too slow.
Yeah.
So it's a bummer, man. But that is what it is. So now that I did Ollama up, I've got an Ollama running. The first time we hit that model, it's going to load a bunch of stuff, which is why I always ask it like hello,
Okay.
just to sort of warm it up.
Yeah.
Okay. So with Ollama running, we can even test, like I have these curl calls, though this is like a tooling one. That's fine. And we'll be playing with streaming anyway. Actually, it's funny because I didn't even add any tooling to this document.
Yeah, it was just like a
Yeah, I don't know why.
stream.
We'll fix that.
But
I should be able to do make curl tooling. And you can see that I hit it, right? It's doing a bunch of stuff. What did I ask it? How are you?
And that's essentially the warm up. All
Well,
that.
this is the warm up right
Or
here.
on that side.
All this
Okay.
for that model. You can see a bunch of stuff that now it's loading the model in memory. It's doing whatever it does, dude. Crazy stuff. But you can see here that with the streaming on, there's the think tag.
Oh,
and then here's every word coming through, which we would normally just sort of stream on the UI. But this is what we're going to get back. So I'm kind of glad I didn't put the tooling piece in here, but the idea would be to put the tooling piece in there. Anyway, fine. So the first thing we need is our ability to talk to Ollama and deal with this. Now, in all the other examples in this repo, I was working with LangChain Go.
Okay.
It's a cool project. It's trying to build all the data models and APIs so you don't have to think about things in raw HTTP. And it has an Ollama package specific for Ollama because Ollama isn't really OpenAI compatible with their API, at least not from what I can see. So the problem, though, is that the Ollama package doesn't support tool calling. Just doesn't support it. Even though it says it does, it doesn't. So that forced me, I lost a day there. So that forced me to take the client that I wrote for Prediction Guard, which is was a Go API, a Go client that was OpenAI compatible, and just steal the bits sort of that I needed. So this client package, what it does is it gives us the ability through a do to execute an API call, in our case against Ollama. And then I added this SSE client, which will let us do the streaming, which is what we're going to use. And then you got just low, like this is regular Go code, but this just gives us basically an SSE client. You can see the scanner for getting each document. Every line is a JSON document. You saw that, right? Every line is a JSON. We unmarshal it, and then we feed it back through a channel. And we do that until the response body is closed and yada, yada, yada. And then really, I shouldn't have called this types for this project. I did it on the other side for reasons, but this is really the models, right?
Yeah.
And so essentially, this is all we need. This is really not OpenAI, but we'll get back model name, time, created, a message, which is a chat message. It could have content. Eventually, it could have tool calls, and the tool call is a function of name arguments, and we'll see some of that. And this is the only sort of data model that we need. And then just to keep the input side flexible, I stole this from MongoDB. I'm using a map, essentially. And I can define a JSON structure, essentially, using this map. Because new parameters come and go, and you don't have to keep changing hard-coded structs. this stuff is solid. Like this doesn't change on the response.
Yeah.
But the request can have a lot of things.
So that's like where when the user types something, that's where that
Well, no, you'll see this in a second.
Okay.
You'll see. It's not when this is the response.
Mhm.
This is for the request. You'll see that in a second.
Okay.
So we have this little thing. So the first thing to do is just, can we write a little chat, a CLI chat tool that can talk to Ollama and do those things, right? So what I'm going to do is just, I'm going to add this hack main. And I'm going to call this package main. And I'm going to have the function main, right?
Yep.
And that's going to call some function called run. Like this is my basic setup, right?
Yep.
And I don't like using panic here. I rather use func dot. Oh, not error F.
I thought it was
dot fatal. Yeah.
It was fatal.
Actually, yeah, func dot fatal line. That's no, dude. Why can't I do this? Func dot. Oh, is it log? It's not in func. It's in log. Log dot fatal. Sorry. Yeah. All right. My bad. Just do that, right? Because that does the OS exit, and that's fine. So, in case anything bad happens there, like this is my basic setup. So, using our new client package, I want to be able to just have a conversation with the Quen model. Okay. So, a couple things. Let's start with this code here. I took this from Thorsten's blog post. It's actually pretty cool. We basically set up a BuffIO scanner on standard in. The default scanner is always to do scan lines. So basically, when you hit enter, that should come back. Then I've got this function, which basically stays in the scan and then returns whatever text sort of came out of that.
Okay.
So this is essentially going to give us support. Every time we call get user message, right, we're basically going to block waiting for the next enter key.
Oh, okay.
And it's going to bring us back the text. So it's a silly little literal function that he wrote that does these three things, essentially. It was cool. Nice, cool little idea, right? Just a literal function. That's all. Oops. So now the next thing is we need a client that we can use to talk to Ollama. That was that other code that I showed you before. So the client API that we wrote is using generics. That way we can say what type of value do we expect back out. And it has a logger function. So anything internal that's happening, we can sort of log. So just like slog or Uber Zap, you get a message and then a set of key value pairs. And so what this little code does is basically take the message, take the key value pairs, not very efficiently, and then just sort of logs everything. It's okay. Like for what we're doing, it's fine. Yeah. We won't get a lot of messages, only like if errors occurring in some Go routines or something. But that gives us a function now that will let us do the same thing that we just did with curl.
Okay.
So that's kind of cool. And then the last thing is this idea of constructing an agent. Sorry, I keep doing that and I'm right here. So we're going to define a type called an agent. It's going to have a client that can talk to Ollama and get back this chat. It has a function that knows how to get a user message from our UI. And what it's going to do then is these two lines here, which will essentially construct a new agent. I didn't bring the new function in. Let's do that. And there we go. Construct a new agent and then tell the agent to sort of run. And I don't need this return because the agent will run will return an error, right? I don't have a context. I don't know what to do with it yet. So we did it to do. That's fine. So essentially now I'll have a client to talk to the LLM. I've got a get user message function that essentially is waiting for a scan on the standard in with the enter. Okay, great. Sorry, I keep doing this, but normally when I'm in class and I'm doing this, I'm going back and forth between two projects, and I'm not doing that here. So essentially now we need a run method. Just do nil. Okay. Amp, don't help me out just yet. So run is that loop. All agents run in a feedback loop. So either you're giving it some information that you're typing in, or we're pulling information from somewhere and giving that back to the LLM. So everything is sort of, think of it almost like, you know how all graphical user interfaces exist in a single loop, an event loop?
Yep.
It's kind of like the same sort of mechanics. Okay. There's just a loop that we're going to have to build.
Gotcha.
We have to determine what to do when on every iteration, but we just need the loop. Okay. So a couple of things here, right? I'm just going to pull it as we need it. So we're going to start out saying, hey, chat with Quen3, use Control-C to quit. That's fine.
Yep.
All right. And then, as I told you, everything ends up in a loop. All right. So just an endless for loop here. Fine. Now, the very first thing that we're going to need to do in this loop is get a user message. So here we are, essentially, and all these fancy escape characters are just terminal controls that are going to give us color 94, which I can't remember what color that is. I think it was blue. And then set everything sort of up. So don't get, like, these things you can look up, but they're just Unicode. /U means Unicode character 001B. Like, we could look up, I've never done this before, but
Escape.
That's an escape, often expressed as X1B Hess symbol, right? And so this is an escape code, like text coloring. Escape, 31M for red.
32M for, okay.
See?
Yeah.
So it's all terminal stuff. So nothing to get like weirded out about. So then we call that function that we wrote, and we'll get back some user input.
Yep.
If they hit Control-C, then OK will be false, and we'll break out of the loop. So when the scanner fails, that's going to be Control-C. The standard in must just go down. And we're getting that. OK. So now we've got some user input. What do we do next? Now, as we know that when we're dealing with a chat system, you got to maintain the chat history.
Yep.
Because you got to constantly feed it back to the model. These are stateless systems.
Yeah.
So if you're not feeding it back to the model, the model doesn't have the context. So that's why you see me doing this. I created this variable called conversation, which is a set of every sort of message that's coming in and out of the system.
Yeah.
We're using the client D. You'll see that in a second.
Now I see the
So what we're going to do here, at least what I did here, is after we get the user input, we want to send that to the model.
Yep.
So I put a fun print here for Quen with the idea now we're waiting on Quen to do something. And then I'm storing whatever the user input was into my conversation buffer. So basically, we're going to append our conversation. And a client D, again, I stole this from Mongo, is just key value. It's a map.
Yeah.
So the role user, because this is from the user,
Yep.
and the content is whatever sort of came in there.
Got it.
I don't know why this is complaining just yet. Yeah, because it's not used. That's fine. Now, we've saved the conversation. Now it's time to talk to the model via Ollama. So we're going to come here. We're going to add this code. So this is what a request looks like, right? And I made it raw so we don't have a ghost struct.
Okay.
So what model we're going to use? The current messages, which the last one is always going to be this last interaction, which is the user question.
Yep.
Max tokens, whatever. Temperature is small. P. All these things, they help with the sort of randomness of the response here.
Yeah.
I can't remember off the top of my head where I got some of these numbers, but the temperature is fairly low here. So we'll have more sort of consistency in the answers. And I'm turning streaming on. So we're going to use streaming. Now, if we're going to use streaming, we have to use the SSE client that I wrote. And you can see the do function. And then what that does is it takes a context. It's a post call.
Mm-hmm.
It's going to take the request document, and then we use a channel to get back the events. Now you can see I needed a URL, which I think I did as a constant. So let me bring that in here. And that's localhost 1143 API chat. If we went back and looked at the curl call,
that's what
we're seeing there.
Okay.
So there's nothing crazy there, right?
Yeah.
And so what this is going to do is make that call to Ollama for the Quen model and put us in that streaming mode.
Mm-hmm.
Nice, right?
Okay. Yeah.
Okay. So once that's done, now we're going to get these responses back. Now, as you remember, or we'll go back and look at it,
we got
responses coming back in what I call chunks.
Yep.
And so we want to display these chunks, but we also have to store these chunks as a complete message for the conversation history.
Okay.
So we need to like gather all the chunks as they're coming in. So what's going to happen is I created this slice called chunks.
You don't need just the content of the chunk. You want
I did. No, I just need the content, which is why I'm saying string.
Okay.
And not
like a JSON.
Not a Go type that's bigger, right? Because the chunk is going to be this whole thing.
Yes.
But I don't need that. I just need the message. So I made it a string. Okay. Now, the next thing is we're going to get all these chunks back. So we're going to have a channel loop with our channel. Mm-hmm. So while there are chunks coming down the pipe from Ollama, this for loop will run. The moment Ollama closes the connection, then this will all sort of shut down and close.
Got it.
That's happening here.
Okay.
So eventually the response body is empty. The scanner will return, and all this will then get closed. See?
Got it. Okay.
So eventually when we get all the data, so it's really important that you finish this loop. You can't just decide to break out of it and keep the response body open. You have to flush it out at least. So we got to keep that. Okay. Now in there, we don't have to do a lot. In this loop for this first version, what I want to know is, was there any content in terms of the message, right? Okay. So remember that a chat is has a message. Yep. And that has a role, content, and tool calls. Mm-hmm. And if you come back here, you'll see message. Yep. Role. And content. In this case, there's no tool calls. That's fine. And so if there's content and it's not empty, we'll display that to the screen, a print. Yep. No lines or anything. And then we'll append that message to the chunks slice. Got it. So we keep a history of that for our conversation. And then the very last thing that we're going to do here, I'll bring this in, is that if we ended up having chunks, then assume we've finished. I'll just do a simple CAD return line feed. And then I'll join all those chunks together using a space, and I'll add that to our conversation. Okay. So our conversation now will continue to grow. Now, one thing that I'll do while we're sort of hacking here, you see me do this all the time. Yep. Is I'll just display for you the conversation. So you can sort of see how the conversation is growing as we iterate back and forth, back and forth. So it's basically, in this case, we type something, we send it to the model, we get back a response, then we type something again, send it to the model, we get a response, and all of that keeps going into our conversation slice and keeps being sent back and forth.
Got it. Okay.
So with this in place, now go run hack. Nice. So chat with Quen. Hello, Quen. And if we come over here, you'll see us talking to Ollama. Boom.
Yep.
So all that's happening. Here is that conversation that we're our history. Now, what's nice about Quen is two things. One, it supports tool calling inside of Ollama.
Yep.
It's also a reasoning model, which is this new sort of types of models that are really good. And so when you see the think tag coming out, that's it's trying to reason what to do.
Okay.
You'll see an AMP, by the way, if I go back to the AMP settings for a second, you'll see an AMP that you have the ability to show the think tags or not. I like seeing the think tags. So I've checked that. So different agents and UIs, or I say UIs for the agents, may give you this sort of opportunity to see the think tags when you're using a model like this that does reasoning. So I'm going to display the think tags just so you can kind of see it. But this is the actual response. So we could do something to just turn off the think tags and you would just see this, but I'm just going to keep that.
And now that response is also added
to, it is.
To
so now if I ask another question, this should sort of grow now on the next thing. I could have put two prints.
Yeah, we would see the hello, the response, and our question.
Do you know what? So like it. Do you know what the weather is in New York City today? Right. So here's now what we sent in terms of now. I did send the think tags here, which is not great because I don't think this adds any context to the actual conversation.
Okay.
And it's just more tokens that we're sending, which means more cost. So in our final sort of solution, we don't want this being part of the message history. That's for us. The only thing I want to see in the message history would be this hello Quen, and then sort of this.
Yeah, like request response.
That's it.
Question
this is
response.
a waste of time and money. In fact, it's probably hurting us more than it's helping us. However, if you see here, it says it doesn't have access to real-time weather. That's one of the things I want to fix. Okay.
Got it.
So it will. That's where the tool calling sort of comes in. But we now have a really simple sort of beginnings of an agent that will let us interact and communicate with the model and have us do things. So I can leave this up, but I don't think, well, I'll just leave it up for now. That way we can test it later.
Yeah.
Okay. So the next step now is how do we do tool calling with the model? We've got to learn how to get it to identify. One, we got to teach it what tools exist. Get it so it can choose to use a tool. If you notice, I removed it, but it was like, I don't have any tools for this.
Yeah. My knowledge only.
We need to be able to do that. So this just requires some new support at the model level here. Now, if we were to just sort of hack this in right now without us doing much of anything else, I can open up the main and sort of step 2 and sort of hack in what the code that's sort of here. So what we're going to do here is we've got to add some new tags. Okay, tools and tool selection auto. This option will allow us to expand the token sort of support.
Okay.
So let me just bring this in for a second, even though it's not going to compile. Because we don't have this concept of get weather. We don't have this concept of a tool document. And I don't want to necessarily bring it in that way. So let's go and look at the tool document method here, which is essentially this. And I'm going to bring this in and just put it here. Wait, let me make sure.
There it is.
Oh, it was going to do it for me. Yay, amp.
Nice.
So this is the definition of one tool. This is what we're telling the model. Okay. So there's a function. Its name is getWeather, and it knows how to get the current weather for a location. And it has parameters. And right now it has one parameter, which is called location. And it should represent like a city and a state. And that location is required. So if you're going to choose to use this tool called getWeather, you have to give me a location.
Got it. And this is the model making that decision.
Model has to do it. So the
Yeah.
model has to be able to reason what location should be used when it reasons
Got it.
that it's going to use this tool.
Makes
Then
sense.
tool selection is auto. And that's basically saying that you don't have to choose a tool. You could say that you always have to pick a tool.
But that wouldn't be good.
That would imply, no, it could be good. That would imply that your agent is just purely tool-based. And if the user's question can't identify a tool, then it's an invalid thing.
Oh,
So
okay.
you may have very specialized sub-agents that whose entire job it is to run a tool. And therefore tool selection wouldn't be auto. Remember, we're in an interactive conversation where it may or may not.
Yeah.
So,
okay.
so in that case, you're basically telling the model, hey, dude, figure out what tool you're supposed to be using. Now,
Got it.
this
Okay.
could be a list of tools, not just one.
Yeah.
We're just playing with this one right here.
That's
So
essentially just defining the tool
itself.
with-
Yeah,
yeah.
the tools that are available and what they do.
Got it.
So
Makes sense.
I'm going to hard code that in there. So this is our sort of tool right here. Now, I mean, on the request side.
Yeah.
Okay. Now, on the response side, there's a couple things that are going to happen. Because if the model wants us to use a tool, there isn't going to be any content. There's going to be tool calls coming in here.
Oh.
So either this is 0 or greater than 0 in terms of length.
Got it.
And if there's a tool call in here, this is going to be empty. But we want to check to see, did the model respond with content or did it respond as a tool call? So one of the things that will change now is in here. So here's our response, right? Right now we're saying if message doesn't equal, if the content isn't blank, just do that.
Mm-hmm.
But one of the things I'm going to add ahead of that is this. Again, we're just hacking here right now.
Yeah.
Just listen to me for a second. So what I'm now going to say first is, hey, were we asked to do a tool call?
Mm-hmm.
I checked that first. If the length of that collection is greater than 0, then we were. Now, I'm going to hard code sort of this as well right now. Which call was it? Now, we only have the one call. So I could just say, was the function name get current weather? And if it was, then I can print out and say that the model is asking for a tool call, right?
Okay.
Kind of cool. And
Yeah.
here's the name, there's the arguments. Now, I don't have an implementation of this yet. So I don't have this, but
Mm-hmm.
just for right now, just for sort of right now, let's do the following. Let's see it say model asking for tool call.
Yeah. It won't.
And just see if it does. Because the next step then would be sort of executing that and sending it back. But I think this is a good first sort of step on where we are, right?
Yeah. Now I'm understanding the tool. So essentially a tool is like a function call. Like it's just calling a function to do some
In this
task.
case, we're saying that our tool is a function.
Yeah.
So there could be multiple types.
Mm-hmm.
I'm going to put this down here too, so we can also see it going into the conversation loop. Okay. So yeah, that's before the call to the LLM and that's after. Okay. So now if I come back and I run this, I can say, hello, Quinn. And that's our
Hello.
message history. And once again, it says, hello. And then
There's
now
a
we've
second.
added that to our message history, right?
Got it. Okay.
Just to make sure it's in there. Now I'm going to say, what is the weather in New York City today? Now, if you look at the reasoning, it says, hold on a second. Something weird just happened. What is the weather today? So, okay, I'm asking for the weather in New York City. Let me check if there are tools. There is a function called getWeather that does that. Let me make sure that JSON is correctly structured with a function name. Okay, I'm going to get rid of this because this is in my way.
Yep.
Now, what I don't like on this case is it reasoned about it. I'm going to do it again, but it didn't necessarily choose the tool in this case. So I got to double check that we're doing it, but it knew about it, right?
Yeah, it didn't.
But it didn't come back
recognize.
and recognize the tool call. So either my little hack is wrong, or we're just going to run it again. Yeah. What is the weather in New York City today? So there's the reasoning, but it didn't give me the tool call.
It's using get weather, but the actual name of the function is different. Get
Ah,
current weather.
so let's see here.
There it is, get weather. That's what it's looking for. And we have get current.
Okay, so that's the problem, right?
Yeah.
Okay. So in my step 2, I called it, yeah. No, okay, that's just me. It's AMP maybe screwing me up. So you can see we didn't see it because I didn't search for the same thing, which is why we don't want to be hard coding strings in here. But that was a good catch. So let's do it again. Hello, Quinn. I just like warming it up. Yay. And then what is the weather in New York City today? There's the think tags, reasoning, and
there's
boom.
a call.
So it's telling us you're going to make the call to get weather, and you're going to specify New York City.
Got it.
Now, we were supposed to make that call and give it back the information so it could then come back and respond to us. We didn't do that.
Yeah, the actual function's not.
So what we need to do is make a call in here. Now, I'm not going to go through all of that. This is more about if we made a call, we have the response, and then feeding it back. So in my case, we could just hard code this for now. Let me take this. We can pretend that we made the call here. So the idea would be, okay, make the API call for the weather. All right. And then if you notice in our, the response is a client D. Okay.
Yep.
So that's going to be that with the get weather. Let's say it's going to be hot and humid and 28 degrees Celsius. And then we'll add that to our conversation. That's the answer to the tool.
Yeah.
Got to put that back in. Notice the role is tool.
Not assistant.
Not assistant, tool. And then we'll just display what that result is. Now what will happen is that's part of the conversation now. So we'll flush all this out. However, we don't want to go into user mode anymore. We've got to now essentially make a call to the LLM again immediately. So we have to sort of know at this point, because we're going to come back up here, not to ask the user, but to send that.
Oh, okay.
So one of the things that I did in step 3, which I'm going to pull out for a little hack here, is I need to know if I'm in a tool call or not. Okay. So the thing here is that
check.
Right. If we're not in a tool call, then we can ask the user and wait for the user to give us some input.
Got it.
So that's the idea, because I want to stay in the loop. I don't want to do side stuff. I want to
Yeah.
go back to the top of the loop. So the idea is if we're not in a tool call, then it's the user's turn to give us something. If we
Yep.
are in a tool call, then we have to now send the results back to the model, and we don't want to do that. So in tool call, no, oh, ask the user. And then after that, we immediately just reset the tool call. Now, to identify that we're in a tool call, what we're going to do is just set this after the conversation. So if I come in here, I can just do that. So
Got it.
Made the call. I have it in there. Say that we're still in the middle of a tool call.
Yep.
And then that will let us skip this and now send that right into the model.
Got it.
And the model should use that information to give us a proper response.
Got it. Yeah, that's just the raw, basically data. Let's say that it's getting back.
Yeah, we got to feed it.
Now you need
in
the
this
natural
question.
language.
So
Okay.
now this time when we run our hack, and I can say, hey, hello, Gwen. Okay. What is the weather in New York City? So you can see here, we gave it that information, then it reasoned, and then it said what? Hey, it's hot and humid. Okay.
Yeah. Okay.
So pretty cool.
Yeah.
Because it said, I don't know, give me the information. Tool call. Here's the information, right?
And then fed it back to the model again to then generate the response.
As a tool, roll tool. Here's your answer. And then it came back and it reasoned using that. Very cool, right?
Yeah.
Yeah.
No, that's cool. It makes sense.
So
very cool.
We now have code here in a loop that would let us.
And then it's skipping the user portion with that because of that flag, right?
Yeah.
The
Yeah, it's just the way I sort of wrote it.
Yeah.
But it's skipping the. Now all this stuff is sort of hard coded in here.
Mm-hmm.
So if we go back to step 3 for a second now, right? We know about scanners and clients, but now what I do is I define an interface called tool.
Okay.
So a tool is some concrete implementation that has a name. It has the tool document that we need to add to the request.
Yeah.
And then it has a function where, given a context and a map of arguments, because if you come back here and look at the tool call, that's a map. Key value map of arguments, then we can do something and return a response.
Got it.
Right? As a client D and or an error. So we take our hack code now. We take our hack code.
Got it. Now I understand what the tool document is. It's essentially that JSON that we have hard coded in there right now. In the client D.
So
that tells you the function name, the description.
Yeah, so now I've got an interface. Okay, what's next? Now what I'm going to do is extend our client to maintain a list of tools.
Yep.
And then just for efficiency, a list of the tool documents that we need to add to every request. We can pre-create all this stuff at startup because the tools aren't that dynamic. Okay. So now when we construct the new agent, we do a couple things here. We now go ahead and create an instance, right, of our tooling. We haven't built it yet.
Yeah.
But at some point, we're going to have a new get weather tool. And then since the get weather tool has to have a tool doc API call, remember the idea is that a tool knows how to render this.
Yes.
That's what the tool doc is. It can pre-do that in that. And then we just add these to do that. Now, let's construct our first tool. And I have this at the bottom. So let me do this at the bottom now. So again, we're trying to get rid of all the hard coding.
Yeah.
Okay. So we're going to have something called get weather. Get weather has to have a name for the tool.
Mm-hmm.
And we're going to have our factory function,
Yep.
which says, okay, this tool is called get current weather.
Which in the hack program,
It
it's...
doesn't matter what we call it. As long as
because we're not hard
we
coding.
can call it
anything.
anything we want,
Yeah.
right? As we call it. Then what we do is extend a method that can get us the name of that tool.
Yep.
Right? I just want to keep it unexported. And then we have the tool doc method, which is essentially what I copied before.
Yeah.
That just, in my case, knows how to produce this JSON or whatever you want to call it,
and
right?
it does the
Yeah.
name.
And it uses the name
Yeah.
sort of there. I think this is the only place the name is probably used. My guess is we could probably fix I don't know if the name's used anywhere else. We'll check. If it isn't, we'll go back and we won't need the name call, but I don't remember if we use it somewhere else. And then finally, you have to write the call. So this is the actual code. Now, again, I want anybody to be able to run this. So I'm not going to go and make you go download an API key. And there's a ton of weather APIs out there.
Yeah.
We can just pretend that we hit it. But this is going to be from the agent's point of view, this is just a call.
That's
expecting to get something back. It's using name here too. So now this is basically, this is our tool.
Got it.
Okay.
Okay.
We want to add more tools. We just sort of do this.
Do the same. Yeah.
And now we've got get weather there. Now we still have to do some work here, right? We don't want to hard code that in here.
Exactly.
So if we come back now to this, all right.
Now it's a tool document.
A tool document. I could have just done this. Okay. Remember, we pre-built all the tool documents in the factory function.
Yep.
Primarily so we could do that. We could have taken that code and iterated it here, but wow, what a waste of CPU cycles over and over again. Wouldn't have mattered, right? So we now have our tool document. So anytime we add a new tool, we get that for free. I don't have to worry about that again. And then we have to do a couple of things here. Now, I don't want to add the thinking tags to the conversation. Remember, I told you it's not adding any value to our lives. So in our loop, when we're dealing with the response, I wrote a little switch statement and a little Boolean flag that lets us know if we're in, if the model's currently in thinking mode or not. And if it is, it just sets this on and off. So we know.
Makes sense.
And then what we do here is I had an if statement here, right? But we need to be a little smarter than that. So I'm going to take this here. And I'm going to bring this in here. Also, no, that's fine. So what's going to happen now is when we get the response, we're going to see, is it a tool call or is it content?
Okay.
Now, if it's a tool call, then the idea is that we're going to call the tools. Now, I don't have this function yet.
Okay.
I haven't or this method yet. So I'll add it here right now. Sorry, this is like a weird part of AMP. So the idea is we have a generic function that takes the tool call response and handles it. And it will return an error or a client D.
Got it.
Now, remember, client D is a map.
Yep.
So if we got back a result from a tool call, we'll add that result to the conversation, and then we'll tell the other side we're in a tool call so it can skip asking the user and do its thing.
You could do that other part.
If the content isn't empty, we'll share that on the screen. But if we're thinking, or we found that last think tag, don't add it to the chunks. Only add chunks, right?
Okay.
If we're not thinking, and that, because remember, I'm trying to reduce
all that, yeah,
all this, none of this thinking is making our life better,
exactly.
right? We need to get rid of these tokens that cost money and it's irrelevant. So all this is trying to do is say, don't add the content chunks, right? Because this is going to be our conversational. We'll display it, but don't add it if we're in thinking mode or anything like that. Now, when we're done with the loop, we check to see if we had any chunks at all. And if we did, we'll just do our CAD return line feed and we'll add those chunks back to the conversation like we did before.
Got it. Okay.
All right. Now,
makes sense.
Actually, we're going to make, and with still some changes actually to this too. So this is the new one now. If we're not in a tool call, then we'll display the content chunks. And if we have any. Now, because we're stripping out think tags, there's going to be extra carriage return line feeds in the content chunks. So this is just ripping out any extra carriage return line feeds that might be in the beginning because we filtered out think tags. Again, they're tokens that we shouldn't be saving and sending.
Exactly.
And then if we do have any content related to this, we'll add it to the conversation.
Okay.
Yeah, so that's what we're doing there.
Got it.
So with that in place, the only thing left is to write our little tool call function. So this code is fairly nice. All right. So given a slice of tool calls, and I've only ever seen it return one, but maybe it can return two. I don't know.
Okay.
Tool calls. And then our list of tools, remember that we created at the top.
Yeah.
If the tool name matches a tool that we have, right? And, we could have done this with a map and been more efficient too.
Yeah. For the sake of
for what we're doing here, it's fine. But, probably a map would be more efficient than the slice of tools up there. And maybe we'll make that change. Then I'm just displaying to the screen that a tool call is being made. Quen's going to respond next.
Yeah.
And then we just call tool through that interface, giving it the arguments. That's why, right, for any tool we have, we don't ever have to touch this again. And then after the call, we can return the response. Worst case scenario, you say that's basically length 0 and nil. And we know already that if we don't get any results, we don't do anything.
Got it.
So this code is really generic. I think the only thing that we could fix would be
the double for loop.
Yeah, so instead of this being, right, this could have been a map string. And then our tools would be more like, and this is where you would need name at this point. The only thing that's a bummer here would be you wouldn't want to do that, right? You would want to do
.name.
You'd have to do it this way. And then it would make sense to have a name. But now we're constructing it twice. And that stinks, right?
Yeah.
And then here you'd say, you could do it this way. See, now it would make sense to have a name exported. Even though everything's in the same package, it wouldn't necessarily be that way. So we can make sort of that change. And then the problem is on the tool docs, it really doesn't matter what the order is, right? This is... we
don't really care about index.
Right.
Just whether...
And then here we would have to do it this way with that length. And then this would have to be an append. Tool docs, tool documents. So we can make these changes. Now you got a map lookup instead of an iteration.
Yeah.
Right. Kind of sucks that you got to do two things here, but if you had a bunch of tools, I think you'd want that level of efficiency. So then down here, now what would happen here is we would just say tool exists a dot tools sub function name. And now you don't even need, let's see what it wants to do. Yeah. See, maybe it's better to say if not exists, return that.
And then I'll do a
Right.
guard clause. Okay. No.
Now, let me see.
Response.
Now, surrounding loop is unconditionally terminated. So let's double check this. We're in a loop. Oh. Well, I do want to break in our case. I don't need to do that. So let's just double check something here. So does the tool exist?
Mm-hmm.
Right? If it doesn't exist, then return.
Yeah.
Though, again, this is more of a loop, right? So maybe this should just be a continue. See?
Okay.
Just in case. So it doesn't exist. Continue. Maybe there's another tool.
Oh,
Then we
okay.
do this. Then we've got the tool call, and then we got the response. So these are changes I'm going to want to bring back into, say, 3 and 4.
Yeah.
Because that's going to be nicer.
And now it's one for loop rather than two.
It's the one loop.
So, yeah.
So, and that gives me a reason to have this name sort of exposed. You should assume this is in a different package, right? So, nice. So now when we call tools, if we get a result, we can send it back, and then it's a matter of just extending it. So let's see if this works now on our hack program. So immediately cap out of range on the make slice. So I did that wrong. Make, oh, such an idiot. In the middle, Sorry about that. So now I say, hello, Quen. Okay, yeah. Hey, what is the weather in New York City today? So you see how clean this is here?
Yeah, much
right.
better.
All the think tags are out. It did tell me to make that tool call. Now you can see that I gave that to it, right, in the context.
And then there it's getting the content from
and
the
then
tool.
It said weather in New York City today is hot and humid.
Yeah.
So what about the weather in San Francisco? Now it's going to tell me to make another tool call. And now it does that.
Got it. Okay.
So let's do the following, because I like these changes. Let's go back to step 3 for a second. And we'll change that out. This then becomes this.
Okay.
And then
it's cool kind of seeing like the magic behind like how an agent would work essentially. And it's just basically reasoning which function call to make.
In this case,
In this case.
So that's our and that's that. I don't want it to return an error here. I just want it to just say there wasn't any tools being called. And but that would be almost impossible because that means it asked for a tool call and we didn't have it, right?
Yes, because we're hitting the call tools
so function. Maybe
tool not found. Maybe.
I don't need any of that.
Yep.
You know, honestly, like I always wonder, like, does it matter I'm using a font if there's no font, right? So that would be there. And then all this is the same.
Yep.
And then I want to do the same thing for 4. We'll make sure 3 is working too, but So step 4 is the next thing we're going to do. But let me bring this back in now. We got this. Step 3, we take this. And I'm going to show you this in a second. But now I've got to do this differently here. So we'll fix this in a second. Fix that in a second. And then none of that changed. The only other thing that changed was this. So let's put this back in step 4. All right. Okay. So in step 3, right, that was our weather. That's what our current hack program looks like right now. It looks like step 3. But for step 4, I wanted to do more of a coding agent. Okay. So we're going to fix that up there. But now the idea is that we only just have to add tools to extend our agent. So I'm adding 3 tools here.
Okay.
I'm adding a read file tool. Read file. You know what's kind of funny here? This is part of the thing, isn't it? So I want to do something here. Like I don't need to make, even though it will get optimized away.
Okay.
Like I don't need to be making the call there. I can use the local variable. That's much more sort of reasonable here. You know what I'm saying? Even though it gets sort of optimized away, I am a method.
Okay.
I have access to the local field. Like,
okay.
Why am I calling name there?
I see.
It makes
I see
no sense at all. Okay, so this is where like these tools are awesome.
Yeah, it just flips through the files for you.
Okay, so let's go back here. So the idea now in our hack program is we've got a get weather tool. We just had to write this code here. And this will just execute any call method. And we just have to go at the top and add our sort of tools here. All right. So let's fix step 4 when we're done.
Okay.
So what I'm going to do is we're going to add some new tools. All right. Let's add a read file tool to our hack program.
Okay.
So I'm just going to come down here and add this code. Now, what does read file do? Read file, right, says it can read the contents of a given file path and use this if you want to see what's inside a file with directory names. So we're going to feed this now to this. And this is what the code does in call, right? It can read a file given its path.
Okay.
And give us back the contents. So this is read file, right? Okay. So I'm going to come in here now. I'm going to do read file, new read file, and add it to our map. Okay, under new agent. And maybe ways to automate this a little bit better too, but that's the idea, right? There's our new read file.
Okay.
I also have list files.
And it's pretty cool that it's essentially the same boilerplate.
Yeah, thanks to the interface.
Exactly.
Thanks to the interface, right? So here's list files. Name is called list files. This can list files and directories on a given path. No path is provided, yada, yada, yada. And what this does is, again, getting the path from the call, can do a walk. Now, for our project, I tell it to ignore everything in zarf, vendor, ven, and git because it gets too big.
Yeah, that'll be too much.
Okay. And I could have really just restricted it to .go files, but I have some Python and stuff in there, right? And essentially, it will just construct a list of files, character, return, line, feet.
Yep.
We can even display what that is, but we'll see it. And then the last tool is an edit and replace tool. And the edit replace tool says, we're calling it edit replace file, replace an old string with a new string in a given file. This has 3 parameters.
Yeah.
The file, the old, and the new. And you can see here, what we do is we read the contents in, we replace the old string with the new string, and then we write the entire file back out.
Got it. Okay.
Okay. Now, in the case of an operation like this, there is no response back to the model. So I'll log to the screen that we've done this, but by sending an empty client D back, we won't go into tooling mode. We'll stay in that user mode.
Okay. It won't go through that
There's
assistant.
no reason to tell the
Yeah.
model that we did it, because there's no feedback for the model at that point. We did it or we did, right? And if we didn't do it, we don't need the model telling our user that. We're already talking to the user directly.
Yeah.
So that we don't need the extra API call or tokens. That just costs money to have the model come back and say what you could have already said.
Exactly.
Okay.
So just printing it is just
That's it. And if
better.
there's an error, then we'll do that too. So there's so that's our third call tool, right? Let's add the tool now. So we got new list files, new list files, new list files, and edit replace files. So here are all our new tools, right? There they are. Boom, 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 boom. Again, because we're using a map, we do it this way.
Yeah.
Now, there is some code on the error. You see how I'll just print the error out and continue if it fails. There's no reason to do again, interact with the model. Now, just because we have this working, I'm gonna steal this code here to get us back green here. Actually, let's just steal all this, right? Okay. Now we don't have get weather on this project. So, okay, good. So this is step 4 is now clean with those new changes that we made, related to using a map. All right, let's go back to our hack program. So now we've got not just get weather, we also have reading files, listing files, and edit replacing files.
Yep. Just
by implementing that behavior in our call function. So let's test out our agent now with these 3 calls. I'm just saying again, hello Quinn. I don't know why I like doing that. Okay, now boom. Let's start with the list files. Hey, can you provide the list of Go source code files in the current directory, right? Now, hopefully it chooses our tool. Let's see what it does.
Wait, list file function.
Sweet, yeah. I think it's going to do it.
Boom, 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 boom.
A lot of reasoning.
Yep.
And this is why you may want to turn that on or off at times. So it does. It picked the tool. Now you can see what we sent it because we're showing this.
Okay.
So you can see here that I gave it all this information. Here are all the files that we found.
Yeah, which is essentially everything except like the vendor, the
zarf. Those things. So it got all of that and went back into a thinking mode.
And it was narrowing it down to just go there.
And then it gave me this response. There's the end of the think. Pretty cool.
Okay. Yeah, right? That's awesome.
Okay. So now what we can do is read the file. Hey, can you give me a brief summary of the, say, contents of this file? So now hopefully it will reason that it should use our So look, I gave it all the code in the
Oh,
prompt.
okay.
See that? So now it has it. It's thinking.
So logger function, agent struct. Yeah. Okay.
Now it's done thinking, and it just told us implements a command line interface that interacts with AI models, and it's giving us
available. Wow.
That's wild, right?
Yeah.
Now we've got one more tool to play with,
And there it is. Wow,
which is the
that's awesome.
replace tool. So we just need something fun to replace. So I'm going to just say package main. Okay, so let's just take this, right? Now, let's say that we're going to replace the word Ollama or something here, okay? Or let's just say we'll replace this just to see if it works.
Uh-huh.
All right, so, okay. So in the, oops. What was that file again? Hold on.
And now the key to this is you have to give it the exact path
Right
because
now,
of how it's
coded. Because of how it's coded. But okay, so let's try it. In that same hack file, can you replace? Oops, what did I do? Shit.
Oh.
I hit enter or something. So let it finish. I didn't mean to do that.
Specific line.
Hit enter.
I'll need the following.
Okay, so
let me know your specific
in the same
requirements.
hack file, can you replace Command tool with CLI?
That's pretty cool. It didn't have the arguments it needed. It couldn't find you, so it asked you for them directly. Already.
Now, let's see if it's smart enough to use the history to know which file I'm talking about.
Yeah.
Because again, is the descriptions that we're using help a lot here.
Exactly.
And its ability to sort of interpret that. Now, what's cool about the AMP agent is that it has tools that know how to go through GitHub history and commits, and it knows how to look up documentation, and it has so all these agents and sub agents that know how to do this. And then the main agent is able to sort of identify, hey, I need more information. Hey, but the model's doing it, really, not the agent, right? Because the model's then told, I have all of this. What do you think? Oh, I would love to look this up. I need this. Feed it back. Now it reasons a little bit more. Feed it back.
Yeah.
Reasons a little bit more. Feed it back.
That's why it gives it that magic where you can type in like a fairly general prompt and
it could start asking questions, but then the agent is feeding it all the answers based on all the tools that it has. And that's a lot of work, right?
Yeah.
And this is freaking crazy.
It's in a loop right now. It's the same two.
So it's in a loop. So
like the thinking isn't changing.
Yeah, so we're in some nasty loop here, right? Because again, it's our first sort of version of this.
Exactly.
So let me kill it. Let's try it again. Hold on. Okay, so give me a summary of the...
Pretty interesting how I got stuck in the same like...
Yeah, now this could be a bug in the model. It could be a little bug in ours sort of thing. I've never seen that happen before. But again, we're sort of hacking this, right? So there, I gave it the contents of the file again.
Let's see, main function calls. Boom, 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 boom.
Did I say be brief? Oh, but there was a lot of thinking, so.
Yeah, this is the actual response, right?
Okay, so what was the path and name of the file you just summarized? So now I'm testing that it's using the previous messages, right?
Mm-hmm. But this one shouldn't use a tool.
No, and it didn't. It said,
Okay.
file I summarized. Okay, so can you edit that file and replace command line tool with CLI? Like, this is a very basic replace, but
Confirm the parameter.
so it,
There it is, edited.
okay, so
Yep.
it did it, the edit. So it told us what tool to use. There it is. And then we did it. So
String command line to.
So if I come back here now, it says CLI.
CLI. Oh, yeah. Okay.
But notice I didn't give it the name of the file again. You're leaning hard on the model
To make that.
to do this, right? The model did this, gave us that path. I didn't have to specify it again. I just said, hey, that file that we've been talking about, let's edit it, right?
And
then it did it, right?
Uh,
Okay, so we've got our little hack sort of program working, and we made what I think is a nice sort of change there, right? So I'm going to do a couple things here now. I don't want to add that yet. Get commit minus am, just so just some minor sort of agent refactor, right? Based on what we just did today. So let me push those up. All right, I don't need to push up our hack tool. Now, something that I wanted to, looks like we're going to do this for the whole show. Hopefully everybody's enjoying this.
I think so, yeah. I think it's interesting.
Okay, so let's do this because it was something that I wanted to sort of hack on. This edit replace is fairly, it's just looking for that string. It could find it 100,000 times, right?
Yeah.
But one thing that I wanted to do at some point is add a tool that didn't just sort of replace, but could also maybe add some code in here.
Yeah, like code gen.
Like I wanted to add to the comments, right? Add this to the comments.
Okay.
Now that's interesting because like if I was going to do this with a prompt, we'd have to feed it the file. The model would have to know, where those comments go. It would have to return back. See, here's the interesting thing. Does it return back the entire file and we just replace it? Or could it tell us what line number to do that with? Now, I could just make sure the prompt, that the question we ask is good, right? But this would at bare minimally would need the read. So let's try something. I'm just kind of curious.
So instead of it making the change and then streaming back the new version of the file, you're saying could it just do the one line? And
see, this is I haven't played with this yet. So,
yeah.
Right. So, so here's an interesting thing, right? Add a new comment at the top of this source code file that says Bill was
here.
this shit. I don't know how that's gonna screw up. Bill was here. And then let's say I gave it this. So let's see what it does, right? So this is where like we need the reasoning because
and this is getting the edit replace.
Now I don't really want it to use edit replace.
No.
But it may not feel like it has a tool for this. I'm wondering.
That's what it just said up there, I think.
Yeah. I was wondering if it would use the read tool, right? Then use the read tool. I give it the code. It makes the change and sends it back down. But it would need another tool to tell us to do that?
I think it would, yeah. It would need to combine essentially the read and then a new like add tool. Oh, it did something.
But it used a replace.
Oh, and
Okay.
it used blank.
Without an old string. So
Yeah.
nothing happened, right? Because there wasn't anything to replace.
Got it.
So I think what we need to do is think about, because at the end of the day, what I've built is powerful, but it's a toy still because I don't have any real.
Yeah.
But
it's a very cool tool though.
All right. So let's just.
It's like endless. No.
Well, that's the thing. I don't have to do anything else but write tools.
Exactly. So it's like.
Okay.
Like it's addicting.
So how about we call this the code editor? New code editor.
Oh. Yep.
This is what we'll hack on for the last sort of 40 minutes that we have.
Yep.
I was going to play with this today, but I might as well do it with everybody here. And we got to change all that, obviously. Yeah, I don't even know if we need. Yeah, we got to change all this. Okay, but that's fine. So let's start with this. What is the description of the code editor? Actually, before we even do the description, what are the parameters? Yeah, I want.
Would need I'm thinking old file, new file, but how do you edit?
See, I'm wondering if we could do. Yeah, this is what I'm saying. So the guys at AMP and SourceGraph.
Like, how do you do it without adding a new file?
This is where the engineering is now, right?
Yeah.
What do we get? Like everything else was bullshit.
Yeah.
This is where you win or lose the game. This is what the Cursor team had to figure out. This is what the AMP team had to figure out. This is what you're paying for.
Yeah.
Right?
Like, how do you...
Everything else is bullshit. If I can do it, it's bullshit.
Yeah.
Okay?
Yeah.
So look, we need the path of the file. Right?
Mm-hmm.
Okay, the line number to change or add code or text. Maybe we need type of change. Okay. Right, so the type of change to make. Now, I wonder if instead of this being a type of change to make, and that could be a add, replace, delete.
Yeah. Not a
maybe a delete. To change to the line number for the code change. So if I knew what file, the line number, the type of change, and...
Okay, I can see that, yeah.
And the change itself, right? Okay, the text to replace the line. I don't like width, but
text or
maybe it's just a replace, but at a line number. The text to, how about this?
Well, the thing is if it's replacing, wouldn't it just use the edit, the replace?
So we'll get rid of that tool and we'll switch it to this one.
Gotcha. Okay, so it'll be one tool that can do...
Yeah, we'll do our code editor tool,
okay,
right?
Gotcha.
So if it can reason about this, the type, I mean the path, the line number, whether it's an add, replace, delete, and then that text, right?
Mm-hmm.
that gets super interesting to me. And then what I'm going to do is we have path, we have line number, type change. We're just going to log this information right now. Because to do anything else is silly. Oh, line. No, that's line. Oh, type change, line change. Line change. Oh, this should have been type change. Type change, right? And I'm going to get rid of all this code for a second. And I'm just going to log this. I wonder why I didn't choose to log path. There we go. Oh, yeah. And then I'm going to return this. Fine. So let's just do that for a long minute. Okay. And
I'm curious about the line number.
I'm going to get rid of the edit replace. Yeah, no, I don't know what it's going to do, bro. Like, I'm hacking on this. This is Bill hacking like he hacks all day. And then you get to see what. So new code editor, right? Okay. Interesting. We could just hack and see if when it chooses it and what line numbers it's sort of choosing. Because until we're getting it to give us the right stuff, we can't code it.
Yeah, exactly.
Okay. So you know me, I can't be rude. Hey, Quinn. Okay, so now what we're going to do is we're going to say, what's a question we can ask it? I'm going to try what I wanted to do, right? Can you add a comment to the, and I go file. Shit, dang. At the top, it says, fuck. No, I'm not doing it. Doing it again.
At the top.
That says Bill was here. I don't know. Let's just see.
Yeah.
Like, I don't know enough, dude. I just know that it.
Code editor.
Okay, tool. Okay, this is good.
Line change.
This is good. We didn't get a line number. Now, it doesn't have...
It doesn't know the file yet.
It doesn't know the file.
It needs to read first.
It needs to read the file.
To get the line number.
So, it didn't know how to read the file first. So, I wonder...
Maybe if it uses that tool, it calls the read.
Now, I didn't give it a reason to need to read the file.
No.
So, okay. Can you...
Well, to get the line number, it needs to read the file, right?
Can you... Okay, tell me what line number contains the words command line in the... You know, when AMP is doing this, they're doing all these things.
Yeah, and it's all basically automated into it.
Right, but they know what order to do things in, how to feed the thing. Like,
exactly.
Like, you know, that's where the money is, right? So it used the tool right. It didn't know line number. It just said top.
First read the file using, then search for the keyword. Okay. Oh, the order's wrong. You just got to add the comment.
Now, I wonder if this is a case where it will give us multiple tools and I'm not going to see it because I'm not logging. I just do the one tool at a time. We might have to log now the tools because.
Oh, actually, tab.
Whoa.
It's getting the line numbers.
It has to read.
It read the file.
What the fuck is it doing, bro?
It's reading the file.
It asked to read the file. I gave it. It's now putting line numbers on everything. Oh, fuck.
It might work.
This is what I was like saying, right?
Yeah.
It
reasoned which.
Oh man, I ran out of tokens.
Oh, is that what it is?
Yeah, I ran out of tokens. That's insane, dude. So
I think it was gonna do it there.
I ran out of tokens.
Because it was at that 1,000.
It ran out of tokens. So it was gonna do it. It was gonna line change.
That was.
It read it. No, that was
before. And then after this, it decides that's where it's thinking. Where they send it first call code.
Here's read file.
Line number 1. Add. Bill was here.
It did this right.
Line number 1. How did it already have 1 there though? Because it didn't do the at line 1. Oh, because the first line, so I guess it reasoned line 1 rather than.
And it was going to do a replace. Yeah.
File.
Okay. So it decided to make the change. Look at what it decided to do.
Add the comment. It's like reversed.
A little bit, but
Read the file first.
but like it was gonna do it. I ran out of tokens, but actually, yeah. Because then we read it. This was in the context window. We don't have to display that anymore. And then in the thinking mode, just ran out of tokens, bro. So, okay. So it was going to do it. It actually gave it to us somehow.
Somehow.
It called it. Line add, Bill was here. Dude, that's crazy. So we got to do a couple things. I'm getting rid of this. I trust that now, right? This is our context window.
The context.
I'll just make it bigger. If it would even let me go that big. I don't know.
I thought the window for Quen was 40.
Yeah, I think this gives you
the max tokens, is that for one?
Oh, that's the max tokens.
Yeah, okay.
We ran out of that. Let's do. I don't remember what this num. Look up num context as relates to Ollama. I don't remember what that was.
It's set to the maximum context size of the model.
If it's set to -1, it allows the model to use. is a parameter that controls the context window size of a language, determines the maximum number of tokens, words that the model can consider at any given time. The context window is the memory. The default is...
That's fine. No, but because we're using Quen,
Yeah, I don't know. Is there a way to tell it unlimited tokens? Because I don't remember. That's like 0, maybe. Do I have
supports a context length of 32,768. Okay.
Well, I said 0 there, so I think if I put 0 here, there's no limit. And I don't remember what this is. But what is it on Quen? It's not breaking.
It says 32,000 on 8B. Here.
I don't know.
Why can't I just get it?
I don't remember why I put that there. I saw something somewhere that told me to do that.
Context lengths, yeah, 32,768.
All right, I'll just leave it there. But I think max tokens needs to be for sure set to 0. Oh, I had 32,000 there already.
Yeah.
I think the problem is not that. I think the problem is that. So we need to double check this. But I think if I say 0 for max tokens, which I should set everywhere, then it won't limit. But double check that on an LLM. Okay, so I'll leave all that this way. All I know is this right now. This here sort of worked, didn't it? When it worked, it worked.
Yeah.
So it would be nice if I could say integer for the line number instead of a string. Okay. So what do we do with this, bro? I have a line number. I have a path. I have a line number. I have a type change.
And then the line change.
I didn't think we'd get this far so quick. So the path is easy because what we need to do. So this is where you want to use like go fumpt and stuff.
Okay.
Because that tooling will give you to do this properly, we need to use the AST.
Okay.
Because you need to read the file into an abstract syntax tree and then manipulate it that way. There is a package in the Go. It's a Golang X package for AST. That's the one I want.
Yeah.
Okay. So this package, yeah, I don't know if I want to go down this path, but this is the stuff you'd have to do. This right here yeah, dude, this is a whole nother world.
Yeah.
But this is how you really have to do it. Inspector. Traversing over syntax tree of a package, including node filtering during the construction. Who is knocking on my door at 12:40? Hold on a second. I know.
Bill left the window open and it's gonna rain. That's Florida problems.
Hold on. I don't know where Alan went. Read that document. We got to figure that out. Hold on.
Cursor type. Let's see. There.
Dude, thank God my neighbors. Allie took the dog to the vet. She left the window down.
Oh my God.
You know, in Huntsville, the kids left the door open overnight because they didn't close it on the other side. I wanted to kill them.
Oh my God.
And it rained. You have no idea.
I'm sure.
Okay,
Mosquitoes.
so look, it wasn't even like mosquitoes, but like rain, so it was like musty, right? So there's, at the end of the day, if you were really going to do this properly, it would have, you'd have to use one of these packages, but I don't remember how to do any of this. I've never done it to this level, but you have to read it. This is what GoFump does.
Okay.
It reads it in and allows you to like make these sorts of changes. Like GoFump, when it's cleaning up your code,
Okay.
reads in the whole AST tree, fixes it, and tells it to
Okay.
to sort of dump it back, right? So
Factoring.
these are like common utilities for working. Add, import. My problem is like AST file. Like I don't know. We're not going to learn how to do this here, but
Yeah. This looks.
But ideally, it would be nice if there was some sort of package that lets you read this in, and then because we're just doing basic string manipulation, right? But
Exactly.
if you're going to add something, you've got to like, it's just not that easy to just do some, we're doing string manipulation, but you have to learn this stuff to sort of take it to the next level. Now that I'm sort of thinking about it.
And that'll do, oh, okay.
I might have to do this offline and see if there's like Golang code edit packages. Like maybe somebody like did this already and made it easier. You know.
I'm trying to.
Yeah, you know, it's like this is all crazy AST stuff. I thought what I found though made it easier. I thought for some reason, I don't know why, I thought there was more support here where you could
I feel like
read a file in. I don't know what an AST file is. That's the problem. Anyway, we're not going to figure this out today here, but I can. This is something I can play with. The bottom line is this, and we're at the top of the hour, so we're fine here. The bottom line is this. I'm going to leave our little hack program here. I'm not going to push it up, but this sort of worked, right? Now it's a matter of what are the changes here that we have. 4.1. Oh yeah, 0. Also, I got to double check the 0 thingamajig. All right, I'm going to commit this code here.
We should probably check the max tokens, right? If that.
Yeah, I think if LLM max tokens setting to 0. I think if you set it to 0. Oh no, 0 was bad.
0 is bad.
How do you do unlimited token? Oh, I thought 0 would mean. All right, we got to play with that before. To max.
The context window limits it, essentially.
Yeah, oh, I'm not turning that on. Yeah, I don't know what the token limit is then, maybe. Maybe I need to look up. What is that, like Quen3 max tokens?
Max output length to... okay. Yarn.
Yeah, I don't know
But there
enough.
was another max tokens.
So maybe I need to just set it to that.
Yeah, like it could take up the whole context window, essentially. The whole...
All right. As long as it works, man.
That might make...
I mean, we're running it locally, so I don't really
Yeah.
care, but it's something that we're going to have to play with. A for amp there. Yeah, on step 1, I didn't really hack that in there, but we can just put it in even in step 1. Okay. Yeah, that's fine. I know we set that stuff. I mean, you get a lot of words with those tokens.
Yeah, that's a long...
But I think we ran out of, because that was so big, you know. All right.
It has to write the however many lines, 200 lines.
Updating max tokens. Okay, so from my perspective, where we're at is everybody learned today sort of how to write an agent and went through the code in example 10.
Mm-hmm.
I think this idea of a code editor was working. It gave us the information I wanted. The question now is like, great, but now you got to actually edit the code, right?
Yeah.
And this would be specific to Go code. You'd also have to know that we're dealing with like with programming language and stuff. You could start to see how
Oh, yeah, it could get
it could be
huge.
Python, it could be right.
Yeah.
But
Ooh.
since I don't have a lot to do right now, what I might do, I'm gonna ask Sharon, the data scientist at Prediction Guard, a little bit more about that max token stuff. But ideally, I think I'm just not finding it, but I think there is a package that lets you read a Ghost code file. It will parse it all out. And I think maybe that's part of the standard library anyway. Golang AST packages. So I think it might be two things. It might be that's Q. It might be using this package, which see given a file.
Not now.
But this is really raw. Like I've played with this before. What I need is something that returns an AST file. If I had an AST file, so how do you open a Go source code file and get back a AST file? I don't know. See, through Go parser and Go token.
Yeah.
So I need the parser, which I don't know where that is. Oh, here's the parser. So look, parse file. See,
Mm-hmm.
I think if you take parse file, you get back an AST file, and then, not you, AST. See, then I can give it that, and you can do things. See what I'm saying?
Yeah. Apply, cursor, insert, like that, those.
Yeah, this is like support for all that stuff.
Mm-hmm. The cursor ones.
I mean, I don't know enough. I do know that this is sort of the way to go. You use the parser, and then you do this. And then you've got this ASUtil, which is probably all we need.
Syntax trees.
Yeah, utilities. My guess is like this is it. You know what I need to do? I wonder if he'll come on the show. So, Alan Donovan
Okay.
works at hold on, Alan Donovan at it's Google. Oh, Alan with one L. Alan Donovan is the one who wrote the Go programming language book. Alan
Okay.
is the one who's written all the tooling for Go. So when you say replace and all that kind of stuff,
Yeah.
he's the guy. He knows the stuff
Okay.
like
So,
inside and out.
yeah.
Now, with what we have, if I could get Donovan to come on for an hour, which is a big stretch, but if I could, then Donovan would basically tell us.
He would know how to.
He would know how to hack on that. Like, now, I've met Donovan before. I've talked to him before. I haven't talked to him in years. But I'm going to reach out to him, and I want to see if he can give us an hour of his time. That would be, yeah,
That would be
that's
pretty
the only
crazy.
way it's
Yeah.
going to happen. It's the only way that's going to happen. So that's what I'm going to do. I'm not going to save the hack program because you have it already on number 4.
Yeah.
Step 4. I'm going to keep it for our purposes here for now. But I think that was a fun 2-hour show.
No, that was fun. I learned.
We didn't do the file transfer, which we sort of need to do.
Yeah.
I think that was fun. I hope everybody sort of enjoyed that, and it was kind of cool going through it. And I'm going to reach out to Donovan today and see if he'll give us an hour of his time.
Yeah.
Because he'll do that so fast, it'll make your head spin, man.
That would be pretty cool. I mean, that's the guy who wrote the,
Yeah, he's the guy. No.
He literally wrote the book.
It's going to the source.
Yeah.
For that stuff. I hope everybody enjoyed the show today that hung out with us. Really appreciate it. And we'll get this thing published now too. So thanks everybody. And Mohammed, make sure you send me that email. Bye.